All right, chapter 3. Here's where it starts getting interesting. We're bringing muscles in. This is a good part. So I'm probably going to divide this particular PowerPoint into two shorter sections just to discuss them. First, we are going to define some muscle terminology. And then we are going to, in the first part, and then the second part, we're going to talk about the structure of muscle from a very small level up to a higher level. And then we will start talking about the function of muscle. So super interesting stuff right here. Love it. So for our learning objectives, we want to define active and passive insufficiency. We will be talking about this a lot, so we'll start there. I want you to be able to describe eccentric, concentric, and isometric activation of muscle. Given a movement example, I want you to be able to identify the agonist, the antagonist muscle groups, and the type of muscle contractions and levers involved, and describe the anatomical components of skeletal muscle, including muscle shapes. So let's start with some terminology. So nature of muscle, the nature of muscle is that it is the sole producer of active force in the body. If we have active force happening in the body, muscle is doing it. So whether it's voluntary skeletal muscle or whether it's peristalsis with our involuntary muscles, a muscle is the sole producer of active force in the body. Of course, there are other structures that are helping it, like muscle without nerve, it's nowhere. We have to have that. We have to have the control. But the muscle stimulated by the nervous system, it contracts and it pulls on bone to create movement. When a muscle contracts, the freest or least constrained segment of the body moves. So in the little diagram here, which is from the book, in the first part of the picture, the distal end of the extremity is the least constrained. And so when the knee extends, the foot goes out in front of her. In the second picture, the proximal part of the body is the least constrained. So when the knee extends, you stand up. So it's what we talked about with closed chain and open chain movements. But when a muscle contracts, whatever is the least constrained is what's going to move. So think about that. There are three types of muscular activation. A concentric muscular activation is a shortening or contracting muscle force. So muscle produces active force and it simultaneously shortens. So in the diagram, that is the classic biceps curl, lifting the 10-pound up. The biceps shortens and the movement happens. Eccentric is the muscle attempting to resist elongation. The muscle attempts to contract, but it's pulled to a longer length by a dominant external force. In this example that we have in the diagram, it's gravity is the dominant external force. So eccentric motions, the muscle is putting on the brakes. You're not just dropping the weight and letting gravity have its way. You are you're using the muscle to elongate and slow down the force of gravity. So eccentric motions are very control-oriented motions, if you want to think of it that way. Isometric muscle contractions, the muscle is contracting, but it's remaining at a constant length. So the muscle is generating active force while it's staying at the same length. So if you're holding a grocery bag, the muscle is contracting, but it's staying at the same length. If you're standing with your knees in extension and your quadriceps are contracted, that's what our quadriceps do a lot. They isometrically contract at the knee to stabilize us. That is an isometric contraction. So the muscle's not changing in terms of length. It's not shortening as in a concentric contraction. It's not elongating as in an eccentric contraction. it's remaining at a constant length, but it's still contracting. So isometric contractions are not rest, the muscle's contracting, but it's staying at a constant length. So the relative points of muscle to bone attachment, the proximal attachment, the attachment that's nearest the trunk, basically, or nearest the core of the body, is considered the origin. It's the point of attachment closest to the midline or core of the body in anatomical position. So if you're standing on your head, your origins and insertions don't move. You're just not in anatomical position. The distal attachment is called the insertion. It's the point of attachment farthest from the midline or the core. So with a normal concentric contraction, the insertion moves towards the origin. Just that, and with a concentric contraction, when the core of the body is the most stable portion. When we'll talk about a reversal of muscle action where the origin moves towards the insertion, and we'll talk about why that happens. So different muscle groups are acting on an individual joint segment. The agonist muscle is the muscle or muscle group that is most directly related to performing a specific movement. Example, the quadriceps are agonists for knee extension. They're the prime mover. You can think of the agonist as the prime mover of the action. The antagonist is the muscle or muscle group that can oppose the action of the agonist. So during knee extension, the antagonist muscles are the hamstrings. The example here, during elbow flexion, the biceps are the agonists and the triceps are the antagonists. So they're not elongating eccentrically, the antagonist. They're passively elongating as the elbow is flexed. So if your antagonist is activated, it's going to fight the motion you're trying to do. That fighting the motion can be a stabilizing effect, or it can be a neutralizing effect. So co-contraction occurs when an agonist and antagonist muscles are simultaneously activated in an isometric fashion. And the example that I use for this is you're standing on a moving bus because you were nice and you gave up your seat to somebody else. And your knee extensors and knee flexors and a lot of other muscles have to contract to keep you from falling down. So you're trying to stabilize by contracting the agonist and the antagonist simultaneously, isometrically simultaneously. A stabilizer is a muscle that fixes or holds a body segment relatively stationary so that another muscle can perform more effectively. So a good example of this is wrist extension for a grip. So try gripping something with your wrist in flexion. It doesn't work as well. Your flexors are put at a disadvantage, but if we hold that body segment still by extending the wrist, you get a better grip. Your flexors can work better. And we will talk more about that specific motion in the wrist chapter. But our stabilizer is really important to the motion. It allows the muscle to perform more effectively. Synergists are muscles that work together to perform a particular action. And we'll talk about, when we're talking about individual muscle actions, muscles that typically act as synergists. So a force couple is a synergistic action occurring when muscles produce force in different linear directions, but produce torque in the same rotary direction. So in chapter 1, we talked about a little bit about force couples with opening a jar where you have the thumb is producing motion in one direction, the fingers are producing in the other direction, and you produce rotary torque in the same direction. And then when you want to put the jar lid back on, you reverse it. So that force couple, we've got opposite motions combining to produce torque in the same rotary direction. The excursion of a muscle is the shortening and lengthening of a muscle. So what is it at its shortest and what is it at its length, as its longest? The difference between those two is the excursion of the muscle. Typically, a muscle can only shorten or elongate about half of its resting length. So it's not going to get any shorter than half its resting length. It's not going to get any longer than 1.5 times its resting length. But it can shorten and elongate. And we'll talk about why that's true. So we'll talk about the importance of the length relationship to muscle tension. So in the next section, we'll drill down a little bit and talk about the structure of muscle on a molecular and cellular and fiber level, and why that shortening and lengthening of a muscle is important.